This year, 2020, at WWDC, Apple started filling the gaps and introduced new SwiftUI specific solutions for things like MapKit, progress views, and activity indicators. There are still some cases where you have a legacy view that you created in UIKit and you want to use that in your own project. Or perhaps you want to use an image and want to use the new PhotosUI framework to pick that photo. And the AlertView in SwiftUI still doesn't allow you to have a text field. Hi, my name is Stewart Lynch. In this video, we're going to discover how you can use UIKit specific views and view controllers within your own SwiftUI projects. The solution is to use a UIViewRepresentable or a UIVieWControllerRepresentable to have SwiftUI and UIKit interoperability. If this is something you want to learn, then keep watching. What you're looking at here is a UIKit solution that has those three things that I mentioned in the introduction. At the top is a custom gauge that I took from one of Paul Hudson's videos. It's designed in UIKit, and when I tap this button, I have it cycle through from 0 to 100 by 20, and as it does, the needle moves smoothly. The second button displays a photo picker from where I can select an image and have it replace the gray box on the main screen. This uses the new PhotosUI in iOS 14, and there is currently no SwiftUI equivalent. In the final example, when I tap the button to enter a name, I'm presented with an alert with a text field. And after I enter my name and submit, the text on my main screen changes to reflect what I entered. This type of alert is currently not possible in SwiftUI. So what I'm going to do today is build an almost identical SwiftUI app that will allow me to use these three UIKit items in that app. You can download the source code for the UIKit app and the starter project for our SwiftUI version from the link in the description below. If you want to follow along, though, you will have to be running Xcode version 12. For this video, I'm running Beta 2. The principles are the same for iOS 13 and Xcode 11, but I'll be using the PhotosUI framework, and that does require iOS 14. Before I look at the SwiftUI starter project, let's take a quick look at the source code for the UIKit app. I've kept the code all in ViewController for convenience sake, but this is not necessarily how I would recommend you structure your apps. The app is designed programmatically, so no storyboard. I've created a number of controls that represent our UI. The first creates an instance of the custom gauge view. It's not necessary to understand how this UIView was created, but if you're interested, you can check out the code in the GaugeView Swift file. The position of the needle is controlled by the value property. Every second one of our controls is a button with a target that performs a task. The setup function takes care of laying them out on the screen in a vertical stack view. The functions are what are required to perform our actions. The moveGauge function simply updates the gauge view's value property by 20 using a time interval with an animation. The getImage function uses the PhotosUI framework to select an image from our Photos library, and an extension of the ViewController sets the image on our view to that selection. If you're interested in finding out how to use the PHPickerViewController, I suggest that you watch the WWDC session, and I'll leave a link in the description below. The code here is basically taken directly from that session. And finally, the showAlert is a standard implementation of the UI alert controller with a text field. It uses a title, a message, and a placeholder for the alert, and when submitted, the alert text on our main view is updated. We're going to be reusing a lot of this code in our SwiftUI project, so I'm going to keep this app open as I code. Now let's take a look at the starter project for the SwiftUI UIKit integration. As you would expect, the layout is much easier to do, because it's SwiftUI. I have a placeholder here for the gauge view and for the image. And the image is currently nil, so a rectangle is being displayed. When we pick an image, it will be placed in this spot with the same frame and scaled to feel like our UIKit solution. The three buttons all call functions similar to our UIKit solution, but they are currently empty. So it's our job to complete them. The first task is actually the easiest one. We want to use the GaugeView UIKit view in our project. So the first thing we do is drag it from our UIKit solution into our project, making sure that we have copy item if needed selected. Now we need to create a SwiftUI view that will represent this UIKit view. The solution for that is to create a file that conforms to UIViewRepresentable. So let's do that. We don't need the boilerplate code from a SwiftUI file. Let's just choose a regular Swift file. And I'm going to call it GaugeViewSUI. This is a SwiftUI view, so I have to change the import to SwiftUI here. Now we need to create a struct that will conform to UIViewRepresentable. And I'll call my struct the same as I called the file, GaugeViewSUI. And this is the SwiftUI view that we will be able to use to display our gauge. And right away we get an error, type GaugeViewSUI does not conform to protocol UIViewRepresentable. If you choose to fix the issue, it presents you with a type alias that is asking you for the type that you want to represent. So in our case, that is GaugeView. If you save this file, you still get an error with an option to fix again. This time, as we let Xcode do the fix, it creates two functions, one for makeUIView and another for updateUIView. And now that those two stubs have been created, we can actually delete the type alias. It was only created to help Xcode know how to create those two functions. MakeUIView is where you create the instance of your view. The context contains your SwiftUI's environment, animation transactions, and something called a coordinator that we'll not need for this simple view, but we will need for our next two examples, so I'll wait until that time before I give an explanation. So with MakeUIView, we'll create an instance of our GaugeView. We can check out our UIKit version first to see how we created the view. We can do it the same way as we did it in UIKit. What I don't need are those constraints. So I'll just copy and paste and remove these constraints. Now the second function will send updates to our UIKit version, and that will be the new value to change the needle position. This function will react to any changes and update the UIKit version. This means that if this SwiftUI view here has a binding to a value and it changes, it will force an update of the parent view. Well then, what in our case is going to change? It's the value. If we create a binding for a value that represents the gauge value, we can update it from our content view's action. So let's do that. We'll create a binding for an int, and we'll call it value. And then within our UpdateUIView function, we can update the UIView, which is our gauge view, with that same 1-second animation that we did in UIKit. Now back in content view, we need to create the state variable for our value that we can pass into our gauge view as a binding for updating. We'll initialize that as 0. Then we can replace our circle with our new GaugeViewSUI, passing on that state variable as a binding. We can resume our canvas and see that the gauge view is shown, and if we preview, our dial goes to 0. Now all that is needed is to code the moveGauge function for our button. Well, this is the same as what we did in the UIKit ViewController. I'll just copy that code and paste it into our function. But we can remove the animation here because we're handling that within our UpdateView function. And since we're updating the value itself, we can remove the gauge view reference. Tapping on the button updates the view as expected. We're done. Okay, let's move on to try and represent our new photo picker. This time, instead of representing a view, we're going to represent a view controller. In fact, the new PHPickerViewController. So let's get started with that. We know that this is not a SwiftUI view, it's a view controller. And as with the last example, we need to create a SwiftUI view that will represent that view controller. But instead of adhering to UIViewRepresentable, we adhere to UIViewControllerRepresentable protocol. Let's start by creating a new SwiftUI file that I will call PHPickerView. I'll change the import to SwiftUI, and because we're going to be using the PhotosUI framework, we need to import that too. Let's start our struct using the UIViewControllerRepresentable. And just as the UIViewRepresentable counterpart, we can let Xcode fix the error. We'll let it create the type alias, and we'll assign it the UIKit PHPickerViewController. We'll save the file and let Xcode create the two function stubs for us. And with that done, we can delete our type alias. If we open our UIKit file, we see the PHPickerViewController requires a configuration, and that configuration defines what things you are going to allow it to pick. In our case, we just want images. So once the configuration is completed, it gets passed on during the instantiation of the picker. So these 3 lines of code here are what we are needed to make our own view. I'll just copy them and paste them into the body of our make UIViewController function and return the picker. There is a new wrinkle, however. We need to use the PHPickerViewController delegate functions and then be able to call these somewhere. And this isn't done in the PHPickerViewController. It's done in that extension to the PHPickerViewController, which conforms to the PHPickerViewController delegate. So as far as the Updateui Controller function is concerned, it doesn't need any code, but we still need the empty function, and it's required. Our app builds, but it's not yet functional. So let's return to our content view so we can present this PHPicker when we tap on our button. And we can do this as a modal sheet. So we need a state variable to do that, and I'll call it showingImagePicker, and I'll initialize it as false. And then within our getImage function, we can toggle that value. Next, we can attach a sheet modifier to our button that will present our new picker view when that value is true. Testing this, we see that we get our Photos album when the button is tapped. Unfortunately, the cancel button doesn't work, and neither does anything happen when I pick an image. And if we return to our UIKit's view controller, we see that functionality is handled in the extension to our view controller. It's the delegate function for the PHPickerViewController delegate. So we need something in our PHPickerView that can handle these delegate functions. And this is the job of a coordinator that can coordinate actions between the view and the delegate. In PHPickerView, we'll create a class called coordinator inside the struct that conforms to NSObject and to the PHPickerViewController delegate. Now it requires one function, and that's the didFinishPicking function. This creates another problem in that PHPickerView, as it no longer conforms to the UIViewControllerRepresentable. We'll let Xcode fix that, and we get a new function called makeCoordinator that returns a coordinator. Well, we have a coordinator class, so let's just return an instance of that for the time being. And I'm going to move this code down below the update function. We also need to do one more thing. When we make our view, we need to specify who is going to handle the delegate functions. Well, that's the coordinator, and the coordinator is part of our context. So when we create our instance of the PhPickerViewController in our make function, we have to make sure that we assign the coordinator as the delegate. And you may recall that the context is an argument of the make PhPickerViewController function, and it knows about the coordinator, so we can type picker.delegate equals context.coordinator. We need to know some way of communicating from within our inner class coordinator function to the outer struct, or its parent. And we can do this by creating a reference to the parent within the class. So we'll let the parent be of type PhPickerView, but we get two errors. Our make coordinator function is expecting an argument now for that parent constant, and the coordinator is complaining because there's no initializer. So we fixed that first initializer problem by creating an initializer in the coordinator, where we assign the parent to our PhPickerView's version of parent. And then in make coordinator, we can now pass self, which is the parent struct, to the coordinator. With this in place, let's work on our coordinator. Let's go back to the UIKit example and take a look inside the didFinishPicking function. We have this code here. I'm just going to copy it and paste it into our coordinator function. And it works except for these two lines of code. Now the second line doesn't even apply to us because we don't need to change an image view's background. In fact, we don't even have one. In our SwiftUI solution, we have an image view that is only displayed if our image is not nil. So we'll just remove that. Next, we see we're trying to update an image view with the found image, when rather we need to update an image view in our content view, and right now our struct doesn't know anything about that. This calls for a binding. So we need to pass in that image view from our content view as a binding so that when the coordinator function updates it, it will refresh that content view. So at the top of our struct, let's create that binding to an optional image. With that in place, we can replace this line that is giving us an error. Our binding is outside of our coordinator class, so we need to access the parent. And this is an image view and not a UI image, so we need to construct the image view using the constructor like this. And the final thing we have to do is dismiss the modal sheet. And we can do that by using the presentation mode environment variable. Back in the parent top level here, we can create a presentation mode variable from the environment's presentation mode key path. And then when we finished picking, we can dismiss the wrap value. Again, we're inside a nested function, so we need to communicate with the parent. So we'll use parent.presentationMode.wrapValue.dismiss. So let's go back to our content view and make sure we pass that image state variable when we present the picker. Let's test this. It works. There are a couple of images in the simulator image assets that are broken. I've reported this as a feedback, and if I use the old image picker, it works fine. Now, debug preview isn't working for me in this beta, so let me run this in the simulator so I can see any console notifications. You see when I pick the flowers, for example, I'm told that there is no such file or directory. You do see, however, that I've added a number of my own images here, and I can pick these and they get displayed just fine. And now on to our last example. In this case, we want to present an alert view with a text field that, when submitted, will update the text field's text with whatever we entered. Well, SwiftUI does have an alert view, but it can't have a text field with it. So again, we have to rely on a UIViewControllerRepresentable. What makes this a little different from the last example, though, is that we do not have any delegate functions, but the wrinkle here is that a UI alert controller is presented on a view controller and not on a SwiftUI view. So when we create our new SwiftUI UIViewControllerRepresentable file, we can't make it an alert view. We have to make it a regular view controller and then rely on our Updateui Controller function to present or dismiss the alert view on top of it. So let's get started. Since this alert view is going to be presented on top of a view controller, which itself will be placed on top of our current content view, we can use a Z-stack that will present the view only when called upon. So we'll go back to our content view and create a new state variable called showAlert, and I'll initialize it as false. And this is what we'll use to trigger the presentation or dismissal of our alert view. Now we can embed our V-stack in a Z-stack or a Z-stack. And at the end of our Z-stack, we'll create a conditional clause where we will put our alert view. And by putting it as the last view of a Z-stack or Z-stack, it'll appear on top of any other views behind it when our showAlert text is true. In our showAlert function, we can toggle the value when the corresponding button is tapped. Okay, so now we can build our UIViewControllerRepresentable. We'll create a new file that we'll call AlertWithTextView. We'll import SwiftUI and we'll create a struct with the same name and, as before, have it conform to UIViewControllerRepresentable. And we can go through that three-step dance. First, we'll let Xcode create the type alias for us, and we'll assign it as a UIViewController, as I mentioned. I'll save the document and then let Xcode generate the two function stubs. For our UIViewController, we're just going to return a generic viewController. Let me remove the placeholder in the update function and remove the type alias. Now, as I said earlier, we want to update the view whenever the showTextAlert value has changed. So we'll need to know when that value in the view is created. This requires a binding for the value that we have in our content view. Similarly, we'll need to pass back any text that is updated. And right now in content view, that is hard-coded. So let's return to content view and add a new state variable that we'll call AlertText and give it a default string of hello ? And then we can replace that hard-coded string in our text view with this variable. Back in AlertWithTextView, we can then create a binding for that variable. Now, our alert also has a title, a message, and a placeholder. So let's create three properties for these here that will be updated when we create the view. We can use let for these properties that they're not updated by our alert text view. They are read-only once they've been instantiated. All three are strings. We have all we need now to return to a content view to create our alert text view. We'll replace our comment with the alert text view, and we'll pass in our two corresponding bindings. And since we're asking for a username, we can pass in name for the title, please enter your name for the message, and full name for the text placeholder. Our content view is done, But of course, no alert will be presented because our alert text view's update function is not doing anything yet. Inside our UpdateUI we only want to present the alert if show alert text is true. So let's create that conditional now. Let's check our UIKit example to see how we do this in UIKit. The first 3 lines of code here are covered because those are our 3 constants that we create when we create our view. So we'll copy the rest and see what needs to be fixed. For the dismiss action, instead of self, which is the alert view, we need to use alert, and we can use the constructor of dismiss with a closure to set our show text alert boolean back to false. That will close our modal. The same will apply here in the second dismiss instance. This line here refers to that UI label, and it needs to change. What we do is assign the string to our alert text binding, so it will cause our view to update and replace our text view with that new string. Now we need to know how to present the alert. Self refers to the parent view, and we are not presenting the view controller on the alert with text view. Instead, we want to present it on the UIViewController. That's the argument of this function. If we run this now in the simulator, however, we get an error. We're attempting to present a view controller from a view whose view is not in the window hierarchy. So what we need to do is wrap that last piece of code inside a dispatch queue.main.async. If we run once more, the alert's presented. There is an error, but it doesn't stop it from being presented. I can enter my name, and I see that the text view gets updated, but our alert text doesn't go away. Well, we can fix that last bug by returning to where we present the alert. And we'll use the trailing closure version to set the show text alert to false once our alert has been submitted. That works, but I still can't live with this error. What we need is to have our alert with text view hold on to an instance of the alert and then release it once we're done. And for this, we need a coordinator. So we've done that before, so let's just create one. Remember, we start by creating a coordinator class that conforms to NSObject. This requires a makeCoordinator function, then we'll just return an instance of the coordinator. In the coordinator, we need to hold a reference for our UI alert controller that we assign when we are in our update function. So I'll create an optional UI alert controller variable that I'll just call alert. And back in our update function, we'll ensure that we only present our alert if it is indeed nil, not already presenting. And we'll use a guard statement to do this. Our update function has the context as an argument, so it's aware of the coordinator, which means we have access to check if the alert in there is nil. If it isn't, we need to return. Once the alert's created, we can assign it that optional variable in our coordinator. So context.coordinator.alert equals alert. And then finally, after dismissing the alert in the closure, we set that coordinator's alert back to nil. And there you have it. Let's run it. And we get no error. All 3 of our UIKit views and view controllers are working in SwiftUI. I hope that this has given you a better understanding of how you can add UIKit views and view controllers to your own SwiftUI projects. I have lots of other videos available and in the queue as well, so please check out the rest of my channel. You can also visit my website to see the apps that I have available on the App Store, and visit my GitHub page to see what I have available as public repositories. If you like what you've seen, give it a thumbs up and subscribe to my channel. And ring the bell to get notified when I post new videos. I'm most active on Twitter, so please follow me there as well to find out what else I'm up to. Thanks for watching.